few more terms that I want you to know about is stems and lemmas. So a lemma is the canonical form or the dictionary form of a word. So am, are, is have the lemma be. If you look up in the Oxford English Dictionary and you look am, are, is, then it will all point to be, and it will tell you that these are the different forms of the word be. So it's like the dictionary form. Fly, flies, flew, flying have the lemma fly. Walk, walks, walked. Walking have the lemma walk. Walker, walkers have the lemma walker. So the reason there's two lemmas here is that here we've got a verb, walk, and here we've got a noun. Stems are the part of the word that is common to all its variants. Okay, so this is different from a morphological stem. Just put that on hold for a second. Here we're talking about just the stem of a word. And this is the part of the word that's common to all its variants. So for instance, produce, production have the stem product. Walk, walks, walked, walking, walker, walks have the stem walk. It's the characters that's common to all of them. But it's not always so clear what a stem is. Do fly, flies, flew, flying have a common stem flew? Or maybe only fly and flying share the same stem fly, okay? And again, your decisions will depend on the specific downstream application of what you're going to do. And I should say, even these definitions that I've given here about exactly what a lemma is and what a stem is open for argument, right? People that write dictionaries can really argue about this and have very nice entertaining fights about this. There's a very nice stemmer in the textbook, which you can read up. It's like, 3 lines of code called the Porter stemmer. It's rule-based, it's crude, but it works pretty well. Okay. In my robot example, I actually like to use a stemmer. So we started with our data set looking like this. We've got all the data here. And then what I did was I started to do some text normalization and tokenization. So the one thing I did was I removed stop words. So these are very short words, basically the function words in a language. Okay, so go, 1, this is maybe a problem. 2, the has been removed. With the has been removed. Okay, maybe a problem. And then what I do is I also use the Porter stemmer to basically get it down to fewer characters. Because remember, what we're going to try and do is we're going to try and match new inputs to my training set. So if I can remove some redundancy in my input and redundancy in my training data, then I might be able to do better matching. So what you can see here is, so the original input was go forward 1 segment to the intersection with the pink flowered carpet. I removed all stop words or function words. Now it says forward segment intersection pink flowered carpet. Okay, and then I ran the Porter stemmer, and I think intersection, it removed the shin, which that kind of makes sense. And with pink flowered, it removed the red at the end there, and then carpet. Okay, and now I can do the rest of my processing on this data.